Hello everyone and welcome back to chapter 2nd of International Webinar Series on Earth Sciences organized by GeoVigyan. Before starting and introducing to our today's presenter, I would like to remind you a few things that you will get a attendance and feedback form in YouTube live chat box section which you have to fill and which will be automatically closed after 45 minutes. So keep an eye on that and you can ask your questions in YouTube chat live box which will be taken directly at the end of the talk to the presenter. So now coming to today's talk. Today we have presenter Dr. David Anomneze, who is a senior geologist in Moni Pulo Petroleum Development Limited, Nigeria. He has done Ph.D. in Petroleum Geology from Nnamdi Azikiwe University, Nigeria. He is a geologist with extensive experience in exploration and development of hydrocarbon resources. He has worked on over 50 oil and gas fields from Nigeria, Ghana, Gambia, Denmark, North America, and many more other countries. He has more than 10 years of experience as a geologist in various companies like Shell Petroleum Development Company, Erin Energy, Nubian Nigeria Limited, Laser Engineering and Resource Consultant Limited, and currently he is working with Moni Pulo Limited. He was the 2015 Best Geology Paper Presenter at the Society of Exploration Geophysicists IGSC conference in Prague, Czech Republic. And today he is here with us to talk on the topic application of geosciences in hydrocarbon industry. We welcome you, David sir. Over to you, sir.
All right, thank you very much, Badola Shubham. All right, I really appreciate this time. It's a rare opportunity to present to the GeoVigyan team and all members here connected. I think I can now share my screen, right? Can I share my screen at the moment?
Yes, sir. Yes, sir. You can share your screen.
All right, just a minute. No. Just a minute. Okay, I think it's saying I have to share from a screen. Let me see what I can do.
Yes, sir. From the Google Meet screen, there will be 3 dots, more option. Then
Okay.
just left of that, present now screen is there, sir.
Yeah, can you see my screen?
Yes, sir. Now it's visible, sir.
I didn't get that.
Yes, sir. Now your screen is visible.
Okay. All right, that's fine. So my name is David Anomneze. I'm very happy and pleased to be here today. It's a rare opportunity to be presenting to the GeoVigyan team, and the topic we'll be discussing today is on application of geoscience in the hydrocarbon industry. And this here is just a sample to show most people are actually aware that geoscientists actually work in the oil and gas industry and help to get the oil out, but they might not be aware of what exactly the geoscientists actually do in such an industry as the oil and gas industry. happening. Okay, so in the course of this presentation, we'll be discussing on the following outline: introduction, career options in geoscience, the role of geoscience in the E&P life cycle, the role of geoscience in the petroleum system elements evaluation. We'll be looking at the energy demand projection. We'll be looking at the industrial and domestic uses of oil and gas. We'll be looking at career advice for students and graduates of geoscience. And we'll be looking about a short story about my career in geoscience. So first, the oil and gas industry is a population-driven industry that is strongly driven by the population growth. And one thing that is very key for all to know is that over time, it has been noted that as the population of the countries of the world is actually increasing, the energy demand is also increasing. However, in recent times, there has been a minor shift in this energy demand. The shift is not just the reduction in energy demand, but rather, there's been an energy mix. So initially, we used to have more of coal, oil, gas, and all in the past, but now we have the renewables coming in gradually to compete with the others. However, we still have just very few level in terms of global usage. Just less than 1.2% of the entire world is still making use of renewables at this time. So we still have a lot of energy demands from oil, from gas, and also from other sources of energy that are not renewable. So if we look at this briefly in terms of the origin of petroleum, one could actually tell that first, the most important thing we look out for is what does a geoscientist do, or who is a geoscientist? And in this context, geoscientists can come from different angles. You can have a geoscientist who actually works in near surface environments for cave inspections, for geohazards and all. But here we're talking about geoscientists who is more like a petroleum geologist for the petroleum exploration business, for the E&P business. In this case, a geoscientist is someone who studies the composition, structure, and other physical properties of the earth with the primary aim of discovering and producing oil or gas. They make use of data of the surface and subsurface to evaluate history and properties of the subsurface. So another question that comes to mind is, where do I fit in as a geoscientist? There are a lot of career options that one can actually, can actually go into as a geoscientist, especially in the oil and gas industry. And these are the options here listed. Now, you can work in as a geologist, a regular geologist that works on reservoir studies. You can work in as a geophysicist that works on geophysical studies. You can work in as a petrophysicist, you do formation evaluation, log evaluation. You can work as a biostratigrapher who does regional chronostratigraphic correlations and evaluation. You can also have those working as geochemists. You can also work on source rock evaluation. You can work as a sedimentologist for those who actually focus on the positional processes, mud logger, drilling mud logs, evaluation. You can work as a well site geologist for those who actually work on the rigs, doing one or two things, on trying to manage the rig operations and the logging operations. You can work as an environmental geologist and a HRC officer who works on trying to understand the environment, what impact the environment has at the time an oil well is being drilled, before and after. So those are different roles. Also have those who work as field engineers. So basically, the field engineers can primarily be working on the LWD, the MWD, mud logging, the logging wide range. Then you have the mud engineers. These mud engineers, many times they're actually petroleum engineers, but also there are things that geologists can actually do as well, because they involve things that talks about the rock formations and the chemicals that we use in the drilling process. They also have geologists working as business development officers. These people are actually interested. Well, their focus is actually to look at how the entire business is and see how to help to upgrade, how to bring in more opportunities. We have them in the producing companies, we have them in the servicing companies. And the servicing companies, basically, they're always looking for opportunities, how they can actually serve the producing companies. While in the producing companies, the business development officer is actually looking for how to sell their products, their crude, how to, improve their resource base, if there are new partnerships that they could actually engage in. So those are the options that the business development officer looks at. Now, also have those who work as IT engineers, looking at how to, like data engineers and all, looking at how to manage the various data that are used by the EMPs and see how they can actually integrate them into more, robust technological processes. Then you have the laboratory analysis, those who analyze samples from your cuttings, from your cores, from a lot of things that has been done. These are the guys that does the laboratory analysis. Then you have the teacher and lecturer. So these people are actually the one who have actually brought so many of us up, who brought me, who brought you, and many of the others up. So what the teacher and lecturer does is more or less you're trying to teach the next generation of young people how to become a better geologist, what they need to know. You try to guide them in a path and give them that necessary exposure that they need. So we also have geoscientists going to work as teachers and lecturers, and really we need people in that field as well. Then we have researchers. These are people who are actually going to just keep making research on how to make the geoscience industry better, on how to see what new methods needs to be applied, what new approach needs to be evaluated, how can we improve it, and the rest of that. So there are a lot of opportunities in the geoscience career. They also have the petroleum economics, which I've almost missed here. They also go into trying to do economic evaluation in whatever you've done so far in your source of evaluation to know if it is economically viable to go ahead to produce or to explore in the field. So if we look at the oil and gas industry as a general, in terms of the cycle, you see that it usually starts from the exploration, it goes to the production stage, to the transportation, to the refining, and to the marketing stage. And the marketing stage is the stage where it gets to every other, end user, like we who make use of it also for our domestic usage in our kitchen and all that, in our vehicles and all of that. So it gets to this end user. But the question now is, where does the geoscientist come in? At what point does the geoscientist come in? So the geoscientist actually come in at the exploration and production stage. That is primarily where our primary skill actually comes into play. So in the exploration stage, what you're trying to do is to identify and locate if there is possibility of finding something like a hydrocarbon here, those things that make the hydrocarbon possible to be trapped in those environments. So they call them the petroleum system elements. So if you're able to do all of those, general evaluation, recognizer, survey, detailed geophysical studies and all and geological studies, and now come up with a prospect, then the next thing that comes to mind is if you're able to drill it and make an exploration discovery and it's economical, you now be talking about production. So a geologist also comes into production, making it possible for you to produce your reservoir in a very profitable manner, in a prolonged extent, and also for you to properly manage your reservoir. In those cases, they have to work in an integrated team, working with production engineers, reservoir engineers, and some other subsurface team, to help come up with sustainable production plan for a particular field. For the transportation, refining, and marketing, the geoscience role doesn't really have any primary skill to apply in there. However, these are roles that you can actually take up as well. One thing about transportation, you don't need a specialty training to go into the transportation sector of the business. You don't need a specialty training to go into the marketing part of the business. And the refining, we have special people who actually go into the refining. So as a geoscientist, there are also those who go into the business aspect of the geoscientists of the oil and gas industry, meaning I'll just try and make up some money and I'll go into the transportation, see how I can negotiate with buyers and sellers. I can even be a middleman trying to connect these two people and still make my profit from them. Or the refining, I try to set up a refining company and I look for investors because I have the facility close to a producing facility. So those are all the concepts that comes into the business aspect of it. But our core area of impact is the exploration and the production. So the geoscientist is going to be the one to tell you if there's a hydrocarbon here, if it is actually economically viable or not. So if we look at also the impact in terms of general life cycle, now focused on the production, on the exploration and the production. So if I look at the exploration and production, the very first thing you want to look at here is we'll start with basin analysis. From basin analysis, you want to do a general reconnaissance survey, do your soil sample analysis, your aeromagnetic studies, gravity studies, your reflection seismic, and all of that. You want to know if it is something that is even worth checking. Now, if you're able to do that and you see from your aeromagnetic analysis that you have enough thickness of sediments there, that you have structural highs that could possibly trap hydrocarbon, and some other people have these non-invasive radioactive methods where they can use helicopters and all to actually make some surveys of the subsurface and tell if there are hydrocarbons or not. So those are things that come into the early preliminary stage. If you're able to confirm that, they go into the acquisition stage. You can now, put in your interest that, okay, I want to go into for this block, I want to pay in for this block, we want to bid in for it, and make all the necessary payments, all the necessary legal documentations and all of that, and due diligence. Then we'll go into what now? Acquiring of seismic. After acquiring your seismic, you want to do a prospect generation from your seismic. Where are the best possible places to drill? You drill your wildcat well. If you make a discovery, you go ahead and drill an appraisal well to reconfirm that the hydrocarbon is quite extensive. After that, if you confirm that the hydrocarbon is there, the next thing you want to do is a field development plan. Then the field development plan is just to help you understand that, yes, I'm actually seeing that there's a progress here. So how do we harness this hydrocarbon? How do we produce it? What value can we derive from it? And all of that. So let's talk about the production drilling aspect. You want to now drill to produce. You're not drilling just to find now because you've already made your findings. You want to produce hydrocarbon and you want to see how economical it has to be. You want to also produce for a certain duration of time. Then you also, in that point, begin to look at your facilities. You want to set your facilities in pace depending on how you want it to be. There are some facilities that you want to be a standalone facility. In some others, you want to pipe it to another facility. So those are different approaches. In those cases, you need to engage with the facility engineer or facility manager to actually develop that. They talk about the reservoir management. So reservoir management is, if we're able to start producing this reservoir, we want to see how can we sustain the production. So if there are sometimes that we look about the choke sizes, we look about trying to check out if you need water injection, if you need gas injection, if you need to do some swabbing of wells in their late stage. And at the end of the day, when you produce your well for so long that you feel there is no so much again in the subsurface, and you take it on to abandonment stage, you need to plug and abandon your well. Sorry. So this is the part here talks about the petroleum system elements, which is the primary things that are needed when you're looking at the entire hydrocarbon system. And what does that entail? What is the accumulation? For instance, you can see the hydrocarbon first is generated at what we call the source rock at the base here. After the hydrocarbon is generated on source rock, it is migrated to a migration pathway that it is trapped into a reservoir. So you have this seal trapping it in place. So all this are different things that the geoscientists actually help you to identify. So it's the geoscientists that tell you first if there's a source rock here. It's also a geoscientist that tells you, is there a possible migration pathway? He also tells you if there's a reservoir here, and he also tells you if there's a seal or a very good trap to actually keep the hydrocarbon in place. So we'll now look at it in terms of the petroleum system elements. Where exactly does each of these geoscience sub-discipline comes in? If we talk about the source rock, for example, which is where the hydrocarbon is being cooked, being formed, it is a geochemist that actually helps us to do source evaluation. So the geochemistry comes in there, do your subsurface evaluation of the source rock. Sometimes you have to take samples, do rock pyrolysis, do visionary reflectance, and a lot of analysis like that will help you to tell if the source rock is matured enough to produce the required hydrocarbon that you need in such environment. They talk about the reservoir rock. So for the reservoir rock, basically it's being done, this is being understudied by the geologist. The petrophysics also studies this, the geophysics does that, the biostratigraphy. What they are trying to do here is you want to look at the reservoir rock in terms of the properties. You want to look at the porosity, the permeability, the water saturation, the rock matrix, and all of that. I want to be able to make your inference that is this reservoir rock good enough? Does it have so much sand, or is it so shaly that the porosity is going to be very tight or highly indurated? So these are all part of the stuff that the geologists tend to make plans to evaluate. They talk about the seal rock. So the seal rock basically is looking at it in terms of geochemistry, the geology, and the petrophysics. So a geochemist is always going to be the one to tell you that, okay, I've looked at this seal rock, these are the properties it has, these are the challenges it might pose, this is seal rock, if it is credible, is it effective enough to seal the hydrocarbon in place, those are some other things to check out for. Then you talk about the migration pathway. So the migration pathway also can be evaluated by the geochemist or the geologist. So basically what they're doing is they want to look at, okay, what particular pathway do you think the hydrocarbon would have followed? It's going to be through faults, or it's going to be laterally migration through, through the sand packages. When I talk about the trap, so the trap also is looking at fault traps. For instance, if you go to most of the trap systems we have in the world, you either have structural trap or combination traps. Those traps have to be identified by a geologist, and it tells you if, for instance, you have a trap, is it actually a structural or stratigraphic, depending on the terrain you're working in, and also if it is structural, you want to be sure. There are a lot of things you look at beyond trap. You want to do attribute extraction and all of that to actually confirm if this trap is conforming to structure, if amplitude is conforming to structure and all of that. So in some other case, you have the stratigraphic trap as well, where you have sand pinch out, where you have channels and all of that. So this actually helps you, the geologist and geophysicist helps you to confirm and check what trap, how effective your trap is. Then you talk about the age at the time, and the age and time in here talks about the time at which this hydrocarbon is formed and the time of migration and time of trapping. For instance, if the time that the hydrocarbon had migrated, formed and migrated, is earlier than the time when the trap, maybe the trap formed late. Let me say the trap formed late and the hydrocarbon had formed early enough. The migration had already formed early enough. As the hydrocarbon is moving, if there's no available trap, it will keep going to and at the end of the day, you keep seeing things like seepage on the surface of rocks. Those are because the trap had not been formed at the time the hydrocarbon was migrating or the time the hydrocarbon was formed in the source rock. So this age and the time, it needs to also be checked and confirmed in place. So also we look at it in terms of the early stage. When we look at the early stage of exploration, one key thing to look at here is what do geoscientists do at the early stage of the exploration? They do a general, reconnaissance survey first, and they start with an outcrop studies. You want to understand the rock there in terms of the rock geometry, the rock properties, the rock, you want to see if there are sands, what properties does this sand have. You want to talk, if you're able to make your if you're able to get some samples of your source rock, potential source rock, where they're outcrop. You want to also evaluate them in terms of their rock cover pyrolysis, victrinary reflectance, and many of that. Then you also want to carry out aeromagnetic survey to actually know how thick is the sediment. For instance, if your sediment is not thick, if your sediment is just 1,000 feet thick, the real fact is that it can't be able to trap hydrocarbon. If it's 2,000 feet thick, it can't be able to trap hydrocarbon. In most cases, it has to be thousands of meters thick. So you're talking about things about 12,000 meters thick, about 10,000 meters thick. Those are things that tell you, with this thickness, there's possibility that the hydrocarbon might be having trapped towards the base of this basin. Then later on, we'll go on to do seismic reflection survey to acquire your seismic data. And after acquiring your seismic data, a lot of things are still going to be done. Now, while you're still doing that, in the geochemistry stage, there are a lot of things that they check out for. They check out for the composition. So you can see there you have the microbes, the algae, the plankton, and many of these things. These what I call them microbes. These chemical compounds that are formed from biological elements, algae and fossils and all, they actually have to be buried in a very deeper environment, not just an anomnesic environment. The reason being, if you look at this illustration, for instance, on these basin illustration, you're going to see that towards the base of the basin, around that deep sea floor, you expect whatever source rock, whatever microbes that has been buried there, whatever fossils that has been buried there, you expect them to be well preserved. And because they have those places are more or less like involved with high temperature and high pressure environment, they're going to be preserved and they will be melted on high temperature to form those hydrocarbons that we're seeing. Now, if for instance you have them being formed at the shallow part of the basin that's closer to the surface, where you have oxygen coming in, at the end of the day, you see that these microbes are going to become immature. So you're having them formed in an immature temperature. They won't be able to form a good hydrocarbon. So there are a lot of things that comes into place when you're trying to evaluate your source rock. And also, when you look at it, there are also different aspects to it in terms of the composition. So if your source rock is formed from microbes from algae, you expect them to be, oil prone. That's when they are from, let me call them fossils. You expect them to be oil prone. But when they are formed from wood, from terrestrial, you expect them to be gas prone. So these are some of the things that they also check out in this source rock evaluation. They also go ahead to do things like kerogen evaluation. So you want to be sure to make what class of kerogen does your source rock come into. And according to Peters and Casa in 1994, they've actually classified into five different kerogen types, of which from here you can begin to make your inferences when you make your source rock evaluation. What ranges do they fall in? Are you in oil? Are you in gas? Are you in a non-producible hydrocarbon zone? So they also talk about the thermal maturity as well. In the thermal maturity, you talk about if you want to know if your source rock is matured, if it's not matured, if it's late, early maturation, if it's a post-mature source rock, and all of that. So at the end of the day, what this helps you to know is that it helps you to know how effective is your source rock. If my source rock is effective, it has the right properties to produce hydrocarbon, then definitely it has to produce hydrocarbon. So what I should then be looking at is my trap. So at the end of the day, for you to actually identify a trap, you need to carry on seismic investigations. This actually start up with seismic reflection acquisition. From here, you can see an illustration of the acquisition process. So you have like your vibrator, which is an energy source sending in information on the subsurface, signals on the subsurface. Then you have your recording, coming in from your geophones. So your geophones are picking in, geophones are for land. Then if you're in water, they call them the hydrophones. They are picking in these signals and recording them into a database. And at the end of the day, after the seismic acquisition person has acquired it, they call these people the acquisition geophysicists. That's what they are called. Those who acquire the seismic acquisition geophysicists. So after they've acquired, they give it to who they call the processing geophysicists. These are different contractors entirely. So the processing geophysicists go in there to look at the noise, remove all the noise in the data, to filter the data, to remove the normal movers and all of that. And after they've done many of those things, they now give it to the seismic interpreters or the exploration geophysicists or the reservoir geophysicists to evaluate. Now, for instance, someone like me actually fall into the seismic interpretation stage because my own competence is not in acquisition or seismic processing. So each of these things, that tells you that the geoscience is actually a very broad discipline. Everyone have where he or she specializes on. However, I still have some basic understanding of what happens in the seismic acquisition stage, of what happens in the seismic processing stage, so that at the end of the day, I don't go ahead interpreting things that are actually not well processed. For instance, there's a data that have been brought to you, and you're seeing a lot of artifacts, and smileys on the data. It tells you that this data has not been well processed, so you might have to take it back for reprocessing. So after I've gone that, we now go on into evaluation of the seismic and the prospect evaluation proper, or reservoir studies proper. So in this case, you've had your seismic, you want to now evaluate what are the signatures I can find on my seismic that I can pick that are like unique in their own sense. So I begin to pick out these signatures, these horizons and events. I map all of them, and after mapping them, I'm able to create maps. So now there are a lot of maps to be created from this. You have a lot of reservoir quality maps, you have attribute maps, you have porosity maps, you have saturation maps, and all of that. Now, when you create all these maps, they help you to understand your reservoir property. And these maps have been created by either a geologist or a geophysicist. You can actually do any of this. Then you also have those who are the rock physicists, who go on to actually look at the rock properties of these changes in seismic images. For instance, if you're looking at the near and the far seismic, you want to see, if I go away from the near to the far in terms of AVO analysis, what responses am I seeing? Is it giving me inference of hydrocarbon presence? Some others, you have to do a lot of cross plots, rock physics analysis and all. Then you also have the well log evaluation. This is actually being done by the petrophysicist. So what the petrophysicist does is he or she is trying to actually look at all the logs that is available and see if this log, what properties these logs have. Are they prolific enough to produce enough hydrocarbon? Or what methods do we have to use now to actually perforate them, to manage them? There are cases whereby if your reservoir rocks are so shaly and you might the porosity and permeability is so low or so consolidated, the reservoir is so consolidated, Sometimes you have to do hydraulic fracturing in time just to improve the porosity. So a lot of things have to come into play. And after you've done most of these studies, a well will have to be drilled. And for a well to be drilled, you have to mobilize a rig to drill this well. And that is what we're saying down here. You have to mobilize a rig to drill this well. Now, when you're drilling the well to target locations as well, you also have geoscientists who come in here as well. You have the well site geology, you have the operations geologists, and also the petrophysicists. What these people actually do basically is they begin to look at, as the well is being drilled, you want to look at the data that you're getting from the well. And I use those data to make inferences in terms of, okay, am I seeing a good sand? Am I seeing a good reservoir? Am I seeing a hydrocarbon bearing reservoir? What hydrocarbon am we seeing? Is it oil? Is it gas? What decision are we making? In some cases, like many fields in Nigeria, the focus is usually for oil, while in some other fields, the focus might be for gas. So you need to begin to make all those decisions from here. And also after drilling your wells, you also collect samples. So you have those who do the mud loggers. They also could do the gas sample, the gas sampling from the gas chromatography. And they do a lot of collection of soil rock samples. So actually they can do further analysis on for biostratigraphic studies, core sampling, and many of all of that. So the geoscientists have a role to play in all of this. The geoscientist is one that will tell you if this is oil or gas. If it is oil, he tells you. If it is gas, if it is water, he or she is going to be the one to also tell you. So it's not a different discipline that does that. That is the role of the geoscientist to tell you if it is an oil, if it's a gas, if it's water. Because sometimes some things like oil, some things can mistake themselves giving response like oil, but they are not oil. So at the end of the day, it is a geoscience that does all of those evaluation and integration to come up with a story on that. Then we look at the environmental aspect as well. So this environmental aspect is very keen. Before drilling a well, for instance, you have to do an environmental impact assessment. In many companies, you have people who act as a HSE officer in those roles. So the HSE officer can either be a geologist as well. Why? Because a geologist understands that, there are changes in chemical properties, changes in physical properties. Because what you're trying to do in those cases is they are first going to look at the environment, they will survey the environment, they'll collect samples, if it is water samples or soil samples from the environment prior to drilling or the early stage of development, and they analyze those samples and give a report of it. So after drilling a well or after producing from that field for a while, you also do another EIA. Depending on the country, in Nigeria is almost, I think it depends on it's about 5 years. Every 5 years you have to do an EIA. So it depends on the country. Every country have their own. So when you do this EIA after some years, you want to actually check what has changed. If, for instance, look at the terms of animals, the kind of fishes that are in the waters as at that time, and when you look at the population or look at the properties of that fishes, when you come later 5 years, are they still the same population there? Or what has really changed? Are these fishes actually dying off? If they are dying off, that means your production is affecting or causing pollution to the environment. So you need to look out for a way to clean it. So the geologists also come in and engage, in looking for better ways to actually clean up this environment. For instance, you've seen cases of oil spill, as you can see here on the screen. So these are an oil spill before and after. So you also need to really want to come up with, a process of how to clean up this oil spill and how to make the environment better. And, those are one of the roles that geologists also can come in as. Then the very big question that most people ask, especially most young geoscientists, students, and early or recent graduates, they look at the question is, are there still opportunities for us in the industry, and how can I get in? It's a very surprising question, but it has been asked. And the answer to that will be seen in a couple of next slides. So if we look at this, in terms of projected energy demand, according to EIA, if we look at the right plots, let's just choose the right plot, for instance. If we look at what we have in terms of oil and gas, we'll see that oil is actually still the higher, more or less, is more like the highest in demand as of 2018. So we have oil in high demand. Now, the prediction now is that if you move from 2018 to 2050, the oil demand is going to reduce. However, natural gas is still going to be very much in need. People are still going to be in high demand. And what that means is that if we're in as much as there might be reduction in oil. And also, let us remember that the reserve of oil is reducing by the day. For instance, the Nigerian reserve of oil some years back was about 40 something billion, but now we're having about 30 something billion. Same with what we have in China. The oil reserve is actually reducing. So no matter what it is, in as much as the demands are reducing, good enough, the reserves are also reducing. But that also means we need to also explore for more oil, because we need more oil for a lot of things. I'm going to show you some examples of what oil has been used for. And also for natural gas. Natural gas demand is going to reduce, but it is not totally going to reduce. In fact, at this time, natural gas demand is going to increase. But the good thing is that there are a lot of gas in the world right now that could actually serve the world for the next 50 years. For instance, the gas reserve in Nigeria can serve for the next 100 years, for even beyond. And these are some of the things that are also being optioned. Also in China as well, they're also looking out for ways to actually look out for what alternative ways they can bring in gases, either through shale gas or through other means of getting the gas to the surface. So if you're able to combine the shale gas, the oil, the normal reservoir gases and all of that, to be able to see that the economy is sustainable. And let us also know is that this hydrocarbon is actually a very good source of income for most countries. So it helps them to build their general revenue in terms of the income to the country to carry out their regular activities for the nation. Now, if you look at that, beyond 2050, another projection is now coming up. And what that projection is saying, beyond 2050, because of the lack of oil and gas at that time, and because of this rapid reduction, a lot of people are going away from oil and gas. Because of this rapid reduction, there will be more like an overshoot of renewables. The renewables become inefficient enough to cover up for the energy demand, because the population will be rising so much and will now come back to need this oil and gas. So there's going to be a different phase of exploration at this time, and there will be rapid exploration to match up to the need for the oil and gas. So they have these, the oil and gas industry actually have these ups and downs, but the fact is that it's going to be a sustainable industry in the years ahead to come. Then we look at the products. What are the products that we can actually get from hydrocarbon? First, you have the oil and gas being used for your vehicles. I believe everyone here have entered one vehicle, either today or within the past 1 week, either going somewhere or within your environment or just moving down the street. In this case, you see that your vehicle is powered by either oil, and more recently, you have more recent vehicles being powered by hydrogen gas. And now this hydrogen gas, they also get it from hydrocarbon, from gases. So they are just byproducts of gases. In as much as there's also a new option of trying to see how they can actually extract hydrogen from the air. So, but those things are still research in progress. Then another thing we look at as well is that apart from the one used for your cars, a lot of other household items like your fridge, your electronic materials, your clothes, your CDs, your games, your drugs, the hydrocarbons are being used in your tires. They are being used in minor quantities in all of these things. So if someone is going to tell you that hydrocarbon is just going to go totally away, then how are we going to produce all these things? So there's no way you tell me that people are going to stop wearing clothes or shoes. You're going to tell me that people are going to stop making wigs. People are going to stop taking drugs and all of this. So the hydrocarbon has one way, one impact to, one value to bring into the society or the other. The other thing is the part of the gas, of which I said the gas is going to remain very sustainable. If you look at the gas, what we're looking at here is what importance or what value does these various components of gas have to bring to the industry? For instance, we'll start with methane gas, which is a byproduct, one of the products of gas. Methane is primarily used for power generation. So currently in Nigeria, gas is like the highest source of electricity in Nigeria today. So that means we need methane for it. Also, for most of our fertilizers, urea, you need your methane gas for it. You talk about the ethane. The ethane is used for your plastic. You talk about the propane and the butane. Those are the cooking gas you use in our various homes. They are made from propane and butane. We talk about condensates. Vehicles nowadays, some vehicles actually make use of condensates. We talk about nitrogen, carbon. So there are a lot of things that actually work hand in hand that we use daily that we can't do without in the years ahead. Because I don't see there's no option yet of people going to use renewables to cook their food in their homes yet. So for now, the only option that has been explored, is maybe they are using geothermal for electricity and all of that. But for cooking, basically in almost everywhere around the world, people make use of gas for it. But that means we'll still need hydrocarbon for our various cooking activities. Then we'll look at what steps. So this is just me saying this time around, what steps are you currently taking to get into the industry? So these are one of the questions that I got to ask people. For instance, you're interested in getting into the industry. What steps do you think you have to take? What steps are you currently taking to get into this industry? Now, one of the very questions that comes to mind is, first, who are those you associate with? Because this will give you the direction to know if you're going to get into the industry or not. For instance, if you don't know anyone in the industry, that means the chances of you getting it, it's very low. Because, for instance, if you're even very brilliant, very smart, and you're going to go for interviews and you're always getting interviews here and there, you need someone who is already in the industry or who is ahead of you to actually give you some guidance and say, okay, this is how we do it here. You have to read up this aspect. You need to know this. You need to know that. You need to be aware of this. So these are things that are very important, so that you don't just make mistakes and go out there and you'll be surprised, and every day you're trying to get one opportunity and you're not getting them because you've not associated with the right people. And associating with the right people also tries to also improve your chances of getting these opportunities. Let's talk about, are you inspired by the dreams of these people you're associating with? So for instance, if you're following someone or you're moving around with someone whom you know doesn't have any future plan in the industry, this person doesn't have any plan in the industry, then that means if your aim or goal is to actually get engaged with that person so that you can be, very keep industry, be abreast of what's happening in the industry, then you actually, you're not following the right person. So whoever you're actually associating with, or whoever the person has to inspire you in terms of their achievement, in terms of their progress, in terms of the little challenges and hurdles that they make, and sometimes they even have to share it with you so that you don't make such, don't go through such challenge. You try to look out for a way to actually make it better for you to cross that path. Then also, are you inspired by the achievement? Does these achievements of this person make you feel, yes, I think I love this achievement. I want to get this. I want to do more than this person has done. Then the last will always be, are you ready to start the journey? The journey is actually a very long one. Many times people are very confused about starting the journey. People are very uncertain, but you just need to be ready to start the journey. Then we'll talk about what exactly you need at this point. So you're ready to start the journey into the industry. One of the very key things you need is information. The information is, a lot of times people come in and tell you, oh, I've been trying to apply, I've been looking for jobs all this while, I've not seen adverts, I've not seen this, I've not seen that. Now, the problem we see nowadays is that most informations are kind of limited. A lot of companies are doing recruitment based on referrals, based on internal information. And what does that mean is that if you're not engaged with one or two persons in these companies, when the opening comes, you might not be aware. And also sometimes even your fellow friends, you might have, if you have a very brilliant friends, for instance, who are actually moving ahead, those are some of the people to also engage with, because they will be aware of what is happening in the current stage, especially for someone who is a year or two ahead of you, or someone who is in the same stage. The person will tell you, oh, I just got in this, I just heard about this, I just heard about that. Have you tried this? Have you tried that? So the more information you have, the better for you. So for instance, if you have like 20 people, 30 people giving you this information, it becomes it's more better. You have more chances than when you just have only one or two persons giving you this information. That means if I have 20 to 30 to 50 people that I've engaged with, I'll be like, okay, if there's anything, you just let me know, please. The more you engage this, one day, one opportunity will come in and they'll remember you, like, oh, I think I just remember there's someone I need to, engage. I need to inform about this opportunity, and they'll get this opportunity to you. So you need to get as much as possible to get the necessary information. Then the next one is the intelligence. You need to also be intelligent enough as much as possible. You want to develop your technical skills, your basic knowledge, your general competence in terms of delivering. Because one thing I also see in the industry is that people are going to recommend you or refer you when they trust that you know what you're doing, that you are good in what you're doing, and that you are focusing so much energy and intelligence in what you're doing. When people, for instance, see that you are not putting in so much effort, they become reluctant in trying to help you or support you. For instance, if your professor in school actually give you an assignment and you leave your assignment and go ahead to watch soccer for 1 week, and at the end of the day, after watching soccer, you are okay that Chelsea or Arsenal or Man U won the game and all of that, and you're not able to deliver your assignment or your homework because of such reason. It gives you some kind of issues. Then the other one we'll talk about is the hard work. We need to be hard work. Hard work means when I engage you in something, do your best and deliver. And what that means is that once you do your best and deliver, you're going to be trusted to actually do more. Then the character. Sometimes there's an old adage that says hard work and intelligence will take you to the top, but your character keeps you going. So there are people who get in the industry and after 2-3 years, they'll get thrown out. I know someone in the industry in my last company who only worked for just 1 month. After 1 month, not even to the end of the month, they had to let her go. And the reason because of this is because of character. Because you are intelligent, you are smart and all of that, but you come into a company and you feel, well, everyone doesn't know anything in this company. I'm the boss here. Whatever you say, I don't care. So you need to understand, you need to have empathy. You need to be able to understand and relate to people, because the industry, you work so much in teams. So you need to be able to, dialogue with people, understand what they want, and try and see how to make peace with them. Even when you meet someone who is a bit troublesome, as much as possible, try and see how you can make peace with them. In that case, when people see that you have a very good charisma, your character and all of that, they're very happy to work with you in the long run. Then, at this time, the next thing that comes to mind is if you're able to develop these skills, you need to wear your thinking cap. You need to keep an open mind for opportunities. The reason I say this is that sometimes people grow up, they start up their career as geoscientists, as geologists, and at the end of the day, they move into the IT sector. They go in to become fantastic data scientists. They go in to become fantastic business development managers. They go in to become fantastic software developers. So you need to look at what is it that I can do differently. And when you can able to identify that thing you can do differently, sometimes this creates a niche for you. Because in the industry today, everyone wants to be a geoscientist, interpreting, modeling these or evaluation these reservoirs. But some other people are actually doing beyond this. We have people in Nigeria, in China, in US, and all of that who are developing softwares. We have a lot of new softwares that come. These people are actually putting on the thinking cap. They try and see how they can do things differently, and they see how to bring in different ideas about all of this. And those are the kind of things that actually bring you out there as a geologist who is more competent. So if you're able to bring those skills, it makes you become up. So either you want to work for someone or you want to work for yourself. They are necessary skills that you need to put in your thinking cap. Think out how you can make things better, how you can improve upon yourself, what value or additional skill can you bring in at the table. And this additional skill is going to help you in the long run. So another thing to know at this point, for all geoscientists, the opportunities now is becoming global. So it's not just a local opportunity. There are a lot of opportunities. For instance, I have people who are actually from Nigeria here are getting jobs in Saudi Arabia, Saudi Aramco, in ADCO, in Oman, and all of that. I also have people who are from China, from India. In fact, we have a lot of Indians in Nigeria working. So for you to see how global it is, and we also have Nigerians, a few Nigerians I know that also work in India. So it's a global industry. The most important thing is for you to know your onions. So once you know your onions and you're able to put in your best to deliver, the opportunity is global, and you will be able to, catch in the right time. Oh, is this tough? Okay, I think this presentation method is not really allowing me to show many of things in my opportunity and my conclusion, but I'll just go ahead. So the final one on the sense of purpose is there are three things to look out for in terms of sense of purpose. And the sense of purpose here is talking about once I interface with someone, for instance, in my 5 minutes of discussion or 10 minutes of discussion, I could actually tell if you're actually going to get in the industry or not. I could actually tell your zeal. I could actually tell your skill. So first thing I'll look at is do you have a passion for what you want to do? Do you have a passion to go into the industry? The second one I'll look at is do you have the necessary skills? Are you building those necessary skills? Are you looking out for how to get an internship? Are you looking out for how to either go for a master's program? Then the next one is what interests you most? So if I see, for instance, you're engaging in professional organizations such as APG, SEG, EAG, and many of these, it gives me interest that, oh, you're rightly heading towards the direction of where you want to be. But if I see you're heading in the interest, you're actually in the social group where they're actually playing music, DJ, and all of that in your community, and you don't know anything about the professional geoscience community, that means you do not have the interest in the society. Your interest is just, kind of maybe not. But if you really have a strong interest, then you need to engage with the society, professional associations, as much as possible. Wherever you find them, you make out time to be there. So here, I just want to tell a short story about my career in the industry. And this short story talks about how I started up as a Shell intern. I actually started up as an intern in Shell. And at that time, I was still more like a novice, trying to learn the much I could learn. I understand as an intern, you can't learn so much, a graduate intern. So I was just trying to gradually learn the much I could learn. I learned a bit of seismic interpretation, horizon interpretation, fault interpretation, creation of maps, and all of that. And after my internship in Shell doesn't retain all interns. In fact, generally, Shell doesn't retain interns. You still have to go through normal recruitment process. So what I did is, while I was in Shell, I was actually looking out for other opportunities. So I was speaking to a lot of friends. I go to conferences, I go to technical meetings, I tell them I work as intern in Shell and all of that, and they're very happy. Okay, yeah, you share your career gradually. So the more I talk to these people, I even meet, sometimes I go for interviews, for scholarships, I meet a lot of young people too, I engage them. So the more I meet these people, the more some of them are going to tell you that they work for one company or the other. Some are going. So the more I engage with these people, they tell me how the industry is, and they tell me how the opportunity is. So when the opportunity comes for Nubian, someone had actually left Nubian to another company, and a friend just called like, "Hey, I heard you've been looking for opportunities. That is why a young geologist just left Nubian to another company. Maybe or maybe not. Maybe I might be looking for a geoscientist." And I just said, "Okay, that's fine." I checked up the address online. I took my resume and went to the company, submitted my resume, and they were like, "Okay," the manager was like, "Okay, how do you know about this company?" I was like, "Okay, I checked up your company on your website. It was a good company, and I felt it was a good place to start off my career after my internship in Shell." And they were like, "Okay, what can you do for us?" And you put it there that, "Okay, yes, I can interpret seismic. How good in it?" I said, "Yes, I'm very good in interpretation of seismic because I've developed my interest and my capacity to be able to deliver good jobs in seismic interpretation." So just like that, and after like the manager just told me, "Okay, you know what? We want to interview. I invite you for an interview. You send me an email of your CV," and that was just it. So after 1 month, I went in there for the interview, and that same day I was recruited, and that was Nubian. So while I was in Nubian, over time, I worked for a service company for a very long time. And I felt at this time, I think I need to move to a producing company because I've long been working for companies, trying to do studies. I've done studies for Shell, done studies for Mobile, done for Ajib, ExxonMobil, Ajib. And I was like, at this point, I think I need to work for a producing company where I could actually help them plan wells, be directly involved in the process, not just doing studies and handing over to them, but do studies, carry out the drilling exercise. And I went on also looking out for opportunities. Sometimes these opportunities are advertised. Some you advertise, they don't call you and all of that. But at the end of the day, I saw Erin Energy. I went up to their website, nice looking website. And I noticed they have an office in Nigeria. It's a US company and they have an office in Nigeria. Fine and good. I went on. I was like, okay, so what do? I'm going to send a message to the CEO of the company because you have an office in Nigeria. And I'm going to tell them, this is what I do as a company for my company. I'm looking for a producing company to actually join to support their subsurface team as a geoscientist. And I went on there. I saw the company. They had a career page. I sent them my CV to their career page. There was no response. I checked out the leadership position there. I was able to locate the CEO of the company. And from the CEO of the company in their website, I sent him an email. And I introduced myself, told him I work for Nubian Nigeria Limited. I'm actually looking for a place to actually practice as a geoscientist in a producing company. I've been in seismic company for a long while. These are my skills. I can do seismic interpretation, well planning, this, and that. And at the end of the day, he just came back like, "How did you get my CV, my resume?" And I was like, "Okay, yeah. So my resume, I actually combine your first name with your last name and your domain email address to actually get your email." Unfortunately, the company was actually recruiting at that time. They were looking for geoscientists, but it was still an internal process. So they had advertised. Some people were called, bringing in people for it already. So what the CEO did at that point was like, "David, you have to join them in the recruitment process." So what I did then, I had to just join them in the recruitment process. Unfortunately, I was the only one that was selected. So that means if I had not made efforts, those other people who actually went for the interview would have one person out of them would have been selected. But because I made efforts, I was invited for the interview because I know I was also good. I took out time to practice a lot. I always try to do a mock interview before going with most of my senior friends. They interview me on a mock interview, ask me a series of questions to prepare me ahead. And I went there, and that was how I got the role. Then after that, after working for Erin Energy for a while, Erin started having some legal issues in US, in Nigeria, and all of that. And I felt, well, at this point, the company was actually going down gradually. I just need to find another company. So while I was still in Erin, opportunity came out in laser engineering. They advertised they wanted a geoscientist. I could as well say, because Lisa was actually a service company. I could as well say, no, I don't want a service company. But I understand as well that Lisa was a good company as well to develop skills. I know a lot of fantastic geoscientists who actually came out of laser engineering. So I put in application there, submitted my resume, and they called me for an interview. I went in for the interview, and I was also selected out of about 20-something people. So at the end of the day, what I discovered was that when the opportunity comes in, you need to also prepare yourself in terms of competence. And many a time, if I go for these interviews, I'll look out for people who actually works there, who have worked in those companies in the past, and I'll make an inquiry like, okay, do you know, what do you expect? What kind of questions can they ask me? What are kind of challenges can they? So I prepare myself for those interviews, and also prepare to be sure that I have the necessary competence to actually deliver on those jobs. Now, even while I was in laser, I knew laser was a service company. I wouldn't want to stay for so long. I want to go back to the producing industry where I worked. And what happened? I started looking out for opportunities. And unfortunately, I applied for a lot of opportunities, and I saw the Moni Pulo advert. So Moni Pulo advert was coming to a different company, a recruiter company, and I saw it, and I applied through the recruiter company. But I know something about recruiter company. Sometimes it is accepted, sometimes it's not accepted by the main company. And I had to check up the company website, look at the LinkedIn pages, and I identified, oh, I know a couple of people who actually worked in the company in the past while I was in Shell. There was one or two guys who actually working in the company then who also did internship in Shell. And I contacted them like, hey, I learned your company is recruiting. What do you think? I introduced myself and all of that we met sometime in Shell. And they were like, oh, yeah, that they had something like that, but they don't know about it. So they went in, make the inquiries, and that was true. And that was how they submitted my resume and all of that. So I still had to go in for the interview. So when you go for surprising is that when you're going for this interview, you see a lot of geoscience is actually coming for the same interview. So that means you need to be good as well. You need to know your onions for you to be able to come out successful. And that's how I found myself in Moni Pulo. And for more than 2 years now, I've been working in Moni Pulo. It's been a fantastic experience working in the company and moving ahead with my career in the company. So this is all the challenges you face one way or the other. And aside from that, even before Moni Pulo, over time, I've gotten, in the past 1 to 2 years, I've gotten over 8 job offers. And many of these times, sometimes I just apply to some of these companies to see if I'm still good enough. Let me just say, am I still competent enough to even work for another company? If I go for this interview, will I be able to do well? So I just go there and I'll still dust the interview and I'll be like, oh, I'm okay, don't worry. You know, that's kind of, so what that tells you is that you are still competent. You still know your onions, you're still good, and you can still be employable. Because if you try that and you're not doing, and sometimes all these things also make you better. So, for instance, if you go for an interview and they ask a question and you do not know, you'll be like, why don't I know this question? And I need to develop skills in that. So those are one of the things you do as a geoscientist to become better over time. Yeah, most times you have to try to attend conferences. I spend my own money sometimes to go for conferences, even though I get sponsorship some other times as well. But I try as much as possible to see how I can keep to pace, in developing my competence, in getting my necessary exposure into the industry and being relevant continuously. All right. So more importantly now, preparation is the key. You need to prepare yourself in terms of your technical competence, in terms of your character, in terms of your engagement in professional organizations. The more people you engage with, the better your career, especially your peers and those who are a few years ahead of you, because those people are actually passing through the same challenges you're passing through. For instance, if you have someone who just got to the industry 5 years ago, 6 years ago, those people were able to tell you what is happening and how to get in. They will tell you what challenges they faced. So you have preparation of your mind. Okay, this is the challenge they face, so I have to prepare myself to actually face similar challenges. So the more you have those people, the higher your chances. So if you have like 50 of those people, you can imagine how much chance. If you have 100 of those people, but if you have just one, your chances are less. because if one doesn't get out something, then you have lesser chances. But the more people you get to engage with, those people tell you, oh, I have these challenges, I have this. So, and one of the ways to actually meet some of these people is through professional organizations, through your university, through a master's program. You need to do a master's program, very important for geoscientists if you really want to continue your practice. For me, I did most of my studies studying and working. So if you're able to do that as well in your own school, you can actually consider that. But if you're not able to do it, you just continue with your job for now. Then see if there's any reason you might want to go back later for a master's when you have so much experience. You can now plan, to go for a master's, and perhaps from there you can find a career of your choice and move ahead with. So that is it for me. Thank you very much.
Thank you very much, sir, for giving the lecture today. And you have tried to build a bridge between academics and industries, which was really helpful for, I think, most of the participants. And by giving the example of your how you joined Shell and then now you are in Moni Pulo industry, how you went from the process and which hurdles you have faced, it will really help us all from the background of geosciences. And sir, now we will be taking few questions which were asked during the YouTube chat live box. You can see those questions in chat also. The first question is from Asif Abbas. Why seismic refraction trace is more beneficial than reflection in data equities?
Okay, so basically in the oil and gas industry, what will make use of is seismic reflection, because seismic reflection has the capacity to actually go to investigate at a very deeper depth. For seismic refraction, it's for near surface investigation, and you can barely use that for deeper evaluation. We know what we're looking at here is most of the deeper prospects in the oil and gas drillings, usually from you have about from 4,000 feet to about 20,000 feet. Seismic refraction is not going to be able to give you that kind of response. So you have to make use of seismic reflection to actually understand how to properly image your hydrocarbon.
Okay, sir. Next question is from Farman Khan. Is there any producing area from the globe which is producing without any proper identification of any trap?
Okay, so basically, you can produce without identification of a trap. So the reason we put it there is that the trap is what keeps the hydrocarbon in place. So without a trap, you can't be able to tell if there's hydrocarbon here or not. Even if there's hydrocarbon there, the hydrocarbon is going to seep off through the seal. So you've said the hydrocarbon find its way out of the rock because there's no trap. So there has to be a trap to keep. So the trap is more like a container. Imagine, let me put it like you have, if you have your Coke bottle, for instance, the cover of the Coke bottle, whenever you shake it, is more like the trap. So what happens is that even if I shake my Coke bottle, as long as the cover is there, the Coke doesn't come up. But once I shake it so much, ignite so much, with that pressure, immediately I open up the cork. The Coke, the drink actually comes out of it, and some gases comes out. So what that tells you is that you need that trap to keep that Coke in place, even no matter how, and that is the way it is. So in the subsurface, there's a lot of pressure. The pressure is so high. So what is immediately the hydrocarbon is formed, the pressure is pushing it up immediately. So it needs a Coke bottle, more or less like a trap, to keep it in place. If not, with such pressure, it will just find its way and keep going up to the surface. And at the end of the day, it sees things like pock marks if it's on seabeds, and it sees things like seepages on lands. That's it.
So next question is from Rajkumar Srivastav. Sir, what is your view on the sustainable development and net zero carbon future? Your field helps find potential drill sites and understand the hydrocarbon content beneath the surface.
Okay, so for the net zero carbon future, I also understand that is actually a very good idea. I support that scenario. I support the plan for the net zero. That's for cleaner energy, But what we'll be looking at here is in terms of we can reduce it, but the likelihood of totally taking it off, it's what is not possible. The reason is, for instance, I mentioned it there, is that we can decide, for instance, there's a reduction in demand for oil. Not really demand. The what's in is demand for it still has high demand for oil. In fact, in Nigeria today, we're actually being told to increase our choke sizes to produce more because there's higher demand out there from the OPEC. But what's more important is that over time, you expect the demand to reduce because we want to go into this net zero carbon. We want to look at renewables and all of that. Fine and good, we want to look at them. But as the demand is going to reduce, the oil, there will be lesser need for oil, but there will be more need for gas. So nowadays, we begin to have vehicles that make use of gas. For instance, you have the hydrogen, vehicles that make use of hydrogen gases. We still have the gas that you have to use for your cooking gas. You still have a lot of gas things that you have to use for power generation. So a lot of sources, and especially for the developing countries, they have so much demand for these things. For instance, that China is among the highest demand of energy, of oil and gas. Same followed by India. India has so much demand from oil and gas, and the demand is going to continue. So if, for instance, a country like India that is demanding so much from oil and gas because of the high population, they need to do so much hydrocarbon exploration so that they can even make more revenue for the country and actually reduce the importation. For instance, you're importing so much of energy, they can be planning some other renewables, but the fact is that with the high population, renewables might not be able to cover the entire population. So you need that's why from the presentation, you don't need so much of hydrocarbon, but you need hydrocarbon to cover some aspect of the energy need.
Thank you, sir. Next question is from Hakim Alam. Mostly exploration techniques are costly and it consumes a lot of time. Can we find some quick and easy methods to predict oil and gas?
Well, if you talk about quick and easy methods, I think the oil and the gas industry, there are no quick and easy methods really. You need to carry out those exploration activities because you know what you want to also get from it. You know what you want to get from it. For instance, if you're going into an oil and gas business and you're going to spend in about $200 million, the reason for spending $200 million is because you want to make $1 billion. So that is just it. So if you're going to spend $200 to make $1 billion, that's simple business. So now imagine a case if someone is saying, okay, I want to spend only $10,000. I don't know what you want to make you $10,000 for. $10,000, like it's better you go into local sales of hydrocarbon, of petrol also, and see how you can do maybe local marketing of petrol in your environment. That's the only way you get. But if you want to go into core exploration, it's very expensive, sincerely, and you need a lot of finances to be able to catch up on it.
Okay. So next question is by Shobit Kukreti. Would you elaborate condensates?
Okay, so condensates are more or less like they are gas that are more or less like liquid they are liquid when they come to the surface. So most cases when you talk about condensates so they are more or less, people put them on the boundary between gas and oil. So they are usually gases in its terms, but at a particular temperature and pressure, they actually accumulate and forming as condensates. And they have their very good use. Sometimes, in fact, they are cleaner oil. Condensates are more expensive than normal gas. So they call them a cleaner oil, and they are being used by most of these recent automobiles, and also a lot of engines actually make use of condensates as well. But they are very clean oil, and they are gases actually. But they are gases when they come. But when they subject them to a particular temperature and pressure, they actually forming as they are cooled in form of oil.
Okay, so the next question is about that. Please tell us about projects going on regarding to find alternatives to oil and gas, as nowadays every country is focusing on electric vehicles. And so how and where you see petroleum industry in next few years or decades?
Yeah, so the electric vehicles and all of that is a very fantastic thing. But one thing you look at in all of these things is, one, you look at in terms of the reliability. You look at the reliability. Sorry, just a minute. You look at the reliability in terms of. Sorry, can you carry this board? So what you look at is you look at the reliability in terms of the long term. the long term meaning, if you look at what is happening to electric vehicles, they are more like they are the main. Is one of the big challenges that the oil and gas vehicles are going to have, because they are depending on battery and all of that. But if you look at the one or two composition of the vehicle itself, is made up of oil and gas byproducts. So you cannot totally rule it out. We can only say, okay, we're going to reduce the demand for oil and gas. We're going to reduce the usage of oil and gas, but we cannot totally rule it out. So what's going to happen is that over time, even the usage of for the electric vehicles, for instance, you also need places to charge it and all of that. If you come to Africa, for instance, Africa's demand for electricity, Africa is not yet able to meet up to 40% of demand of electricity, for instance. So if someone's going to tell you that electric vehicles going to work in Africa, the limitations are there. The uncertainties are there. For instance, if it comes to Nigeria, I can tell you electric vehicles in Nigeria, they're now up to 0.1%, and they're not likely going to be up to 1% in the next 10 to 20 years. So those uncertainties are there, and they are also very expensive. So you have a lot of issues, limitations here and there that you still want to stick to oil and gas till there's a better technology. I also believe with over time, there's going to be a better technology to actually optimize these electric vehicles, make them better, more durable, and cheaper to consume. But the fact is, the oil and gas is going to remain. The relevance might reduce over time, but the impact is still very strong.
Thank you, sir. The next question is from Hakim Alam. Can you please tell us about skills that we need to learn to become a competent industrial geologist? And adding to it one more question, that what type of software should we should have knowledge of while joining petroleum industry?
Okay, so let me start with the last question. So for the software, basically a lot of fantastic software out there. For instance, depending on the role you have to play, as I mentioned, you have geochemistry, you have geology, you have geophysics, petrophysicists, you have rock physicists, we have the mud loggers and all of that. So these people actually make use of varieties of software. But one software that resonates with me personally, I'm not a processing geophysicist or acquisition. I'm more of a geologist, a geophysicist. So I do interpretation and modeling with QI. One software that resonates with me more is Petrel. The Schlumberger Petrel is more like, because it's a universal software. It's been there in the market, and over 98% of companies in Nigeria and 98% of companies, let me say 98% of companies in Nigeria and over 80% of companies globally make use of it. So what that means is that the chances that I'm going to be hired by a company because I know how to use Petrel is higher than the chances of I'm going to hire for a company because I use other software. So those are one of the things to actually look out for. For instance, even when I joined my second company after my internship, they asked me a question that, what software am I able to use? And I told them I can use Petrel. And they were like, okay, that's fine. That's what they want because that's what they use there. So imagine if I had gone there and tell them I don't know how to use Petrel, that's just going to be it. Because they also understand, as much as you know the competence, they want to be able to make use of the tool. Most companies don't want to train people from the scratch. That's another uncertainty, especially for smaller companies. They want to train you from a particular stage upwards. So you have to look for how to develop yourself from that scratch to a particular stage that they might be needing you, so that from there you can actually move ahead. So that's just basically, so if you're able to develop your skill, the primary skill most times I actually tell people to go and develop how to carry on seismic interpretation and petrophysical evaluation. Those two things are like the primary. Once you can do interpretation of seismic, you can do petrophysical evaluation. That is the primary thing you need. The reason I say that, if, for instance, you're going to bid for a block in Malaysia, if you're going to bid for a block in Mozambique, you're going to bid for a block in Guyana, you need to know how to interpret the seismic. If not, someone can just give you anything as a block and you take it, and before you know it's your company. So when companies are calling, I have many people who call me many times and be like, okay, I want you to come and help us evaluate these assets. We want to buy into this asset here and there. We want you to just do a quick check and all of that. You're calling here because you are very good in seismic interpretation and you're also very good in petrophysical evaluation. But if, for instance, you're not good in any of this, or you're good in only petrophysics is actually fine and good, but it has a limitation. It's a specialty skill as well. But I look out for those who are starting up newly. If you're starting up newly, try as much as possible to see how you can combine these two skills. It will help to increase the chances that you will get a better opportunity.
Thank you, sir. Next question is from Yamini Malhotra. Being an explorer petrologist, have you ever converted hydrocarbon into DNA to synthetic diamond? If yes, under what temperature and pressure, and by which scientific techniques?
Well, I am not an exploration petrologist. So I beg to that. I don't know how to convert hydrocarbon into diamond as well. So that's new to me. Maybe that might be your own specialty skills that you might be the one to teach us, but I really don't know how to do that.
Okay. So next question is: are there inorganic sources for petroleum and natural gas?
Well, I don't think there are. They are all organic. They are all organic. They have to come from byproducts of either trees, plants, or or microorganisms. I don't think there are organic sources for inorganic sources for petroleum. There are none.
Next question is: are there any recent approaches for hydrocarbon exploration using gravity data?
Yeah, so the gravity data, it's more on the early stage of the exploration. So most times we make use of the gravity data to identify structures, to identify faults, in the subsurface. So that's apparently, and they use that to also understand the thickness in terms of the thickness of sediments away from the underlying basement. For instance, in some areas you have a lot of sediments on top of basement, so they want to be able to separate this. So those are one of the things that it does. It helps to identify faults, so that with your faults you can know, okay, what are is there a particular trapping system here? What are the fault dimensions that are here, and what is the possibility that these faults can be serve as a hydrocarbon migration pathway? So those are some of the things that you look out for. So it's on the early stage of exploration that you bring in gravity data. You don't bring in gravity data when you come to the final development stage of your field. It comes into the early stage.
Thank you, sir. Now coming to the last question of the session. How can one establish hydrocarbon type threads and distribution across a producing field using well log information?
Yeah, so when you mean hydrocarbon type, I want to believe that is you're talking about in terms of fluid type, that's oil or gas. So if you're looking at oil or gas, you want to do a distribution across a producing field using well log information. So you can do that. It makes it there are a lot of Excel spreadsheets that they use for that. So what actually that's more like a fluid distribution chart. So what the fluid distribution chart does for you is that it helps you to show, okay, for instance, this well has oil, this other well has oil, this other well has oil. You want to see if the three wells, if they're actually having the same contact, the hydrocarbon contact to the water is the same, or if they are different. If they are different, what could be the cause of this? So, for instance, if a well was drilled in 1990 and that well is producing, and another well was drilled in year 2000 and that well is producing, the contact won't be different. It won't be the same thing. The contact would have changed because the earlier contact, for instance, if I drilled a well in 1990, the contact, let me say, if the contact is 5,000 feet deep. If I come by 2020, that contact might have gone, instead of 5,000 feet deep, I might be getting 4,950 feet deep. That means the hydrocarbon has gone up, and that is because it's oil. Now, if it is for the case of gas now depends on two cases. Is either it's an expandable gas or non-expandable gas. So if the gas is expanding, as you're bringing your oil, the gas will keep expanding, keep coming down. So gas instead of going, so if your gas was actually 4,000 feet, your gas can come down to about 4,100 feet. So your gas naturally expands if it's an expanding gas. But if it's not an expanding gas, it will remain where it is. But when you keep producing it, definitely it's going to reduce over time. But the most important thing is that the fluid distribution chart is done. They usually do it in Excel spreadsheet. You can also do it in your petrol software, but most of the time in the industry, we make use of Excel spreadsheets. They have templates already. Excel templates that are linked to PowerPoint. Once you just fill in those data into your Excel templates, it automatically generates the charts for you in the PowerPoint.
Thank you very much, sir. Once again, we thank you for enlightening us with your knowledge and industrial experience. Thank you very much, sir. Sir, would you like? Yes. So would you like to say something to participants?
Okay, mine is just a word of encouragement. I understand that for geoscience, especially for the early coming ones, that the industry is a bit tight at this time. There's a lot of challenges in terms of transition. A lot of people are scared. Hey, are there really opportunities for us out there? Are we going there to meet? So what I put it there is that whatever your hands find doing, do it well. So what that means is that if you're actually an undergraduate, you need to start engaging with professional organizations, attend conferences. And when you attend conferences, meet a lot of people, talk to them about some of the things you're looking for. And you might be lucky. That's one thing. You might be lucky you find yourself in the oil and gas industry, because I believe there's also a bit of a luck. In fact, to me in general, I believe every successful person has a bit of luck in it. So you might be lucky enough to find someone who just tell you, oh, I think this company is recruiting. Why not try? You apply for it. Now, when you're going for interviews, as much as possible, do a mock interview. Meet someone you trust, who you feel is a bit more experienced than you. Let the person, put you through some questions. And from that, you can never tell, you can start up your career and as well keep growing through your career. But what's more important is, as you grow in your career, always look towards a goal. Try to always make yourself competent, because I see a lot of people at the time when they get into the industry, they become so relaxed. Like, oh, I think I'm now there. I have a good house. I have money. I have a car. I have everything I need. So there's no need of me reading anymore. No need of me going to conference. Let me just work and you pay me salary. And at the end of the day, when there is downturn and your company unfortunately lets you go, these are the people who become more miserable. The reason they become more miserable is that they didn't prepare for the uncertainty that might come. But when you prepare, knowing that, yes, I've developed my competence, I know a lot of people, and these people also know that I'm good. So when even there's an issue here, I can move to another company. So if my company is having an issue, I move to another one. If there's just like that, so you can move because you've created that pattern for yourself. You already know your competence in delivering your job. You put in your best, and you come out with the best as well. So that's my little point of advice. And I appreciate you all for setting up this team. It's a wonderful one talking to you people. This is my first time engaging with a lot of team from India. I have a lot of guys from India also that I work with in Nigeria from Slumbeje. They're actually doing one or two things for us. And I also have some friends, also in IIT, in Mumbai and all of that in India. But it's a good one being here today with you all.
Thank you very much once again.
All right. So I think this is the end of the show.
Yes, sir.